Hello, Stats Jedi here with an interesting question for you. You may have seen this before. This is called the Monty Hall problem. There is door number one, door number two, and door number three. One door has a brand new car behind it. The other two doors have goats behind them. To play the game, we start by picking one of the three doors. Let me go ahead and pick door number one. When I pick door number one and click on it, the way the game works is that Monty Hall opens up one of the other two doors. And he shows me door number two has a goat behind it. Now, do I keep my choice or do I change it? Following our intuition, you would think before any doors were open, there would be a 1/3 chance of having the correct door. Now that the middle door has been opened with a goat behind it, we see that there are two possibilities for the car, and there's no reason to think there's any difference between these two doors. I have a 50-50 chance of having the correct door. So I'm going to go ahead and keep my choice. Oh no, the car was behind the third door and I lost. Let's tap play again. This time I'm going to choose door number three. Door number one is opened. There's a goat behind it. Do I want to switch to door number two? I think I will switch. I'm going to change choice this time. Click on change choice and I won. Great. Let's play it one more time. Say if I pick door number three and there's a goat behind number two, I'm going to stick with number three, keep choice, and I lost. So we could keep doing this over and over, and this is supposed to keep track of how many times we won or lost. And you can do that if you want, but I want to show you something that will explain this problem much better. Let me stop the share here for a moment. And now let me explain what I've drawn up here. So car could be behind door number one, door number two, or door number three. Equal likelihood for each of these. Keep in mind there's equal likelihood for all possibilities that I show you here. So the next line is, what door did we choose? Before anything is opened up, we could have chosen door one, two, or three. In every one of these cases, regardless where the car actually is, the doors are all closed. We could initially pick any one of the three doors. There's 9 possible ways this could play out. Now, what door could they show us? If the car is behind number one and I chose door number one, then he could show me either door two or door three with equal likelihood. That's why I list them both there. However, if the car is behind number one and I chose door number two, the only possibility he can show us is door number three. So that's why I list three here twice, because all the probability has to go to door number three in that scenario. Now, if the car is behind number one and I chose door three, likewise, he could only open door number two for us. And so I put all the likelihood on door two there. So that way you see the possibilities here. And I do the same thing for car two, car behind door two, and car behind door three. Now, what happens if I switch doors? If the car is behind one and I chose number one, if I switch, with two being opened, I have to switch to three. If three has been opened, I switch to number two. Same logic. If the car is behind one and I chose two, he shows me number three. If I switch, all I can switch to is number one. Okay. So logically, I filled all this in. And so now look what we have. If I stay put, whatever I chose, that is what I have on the stay put line here. So these are just 1, 2, 3. Okay. Same as my initial choices. But here's what we want to do. If I switch, there are 18 possibilities here, each having equal likelihood. How many of these do I win the car? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 ways of winning the car out of 18. That's a 2/3 probability of winning the car if I switch doors. If I stay with the same door, look down here, there are 9 total possibilities, and only 1, 2, 3 ways out of those 9, 3/9 probability is 1/3 probability that I win if I stay put. And so this is very strange. It goes against my intuition and probably yours, that you are more likely to win if you switch doors than you are if you stay put. If you'd like more information about probability, like more problems about probability, if you need help with studying first year statistics and probability, you need to go to statsjedi.com, where I can give you some testimonials and where you can give me your information, which will send me an email, and I will do some tutoring with you if it's a good fit. So that's it for today. We'll see you next time. Take care.